Hello everyone and welcome back. What's going to happen right now is we're going to start working on our Python program for the binary search tree. Again, binary search trees or binary trees as a whole are very simple to doubly linked lists. And especially the node class, what's happening is we're just going to change the names in it, but it is the exact same node class as we had with binary trees. With doubly linked lists. We're going to start programming right now, and as you can see, it's going to be the class node. It is the exact same class from before. We're just changing the name. So we're going to start with $init, and it's going to receive self, and instead of data, we're going to call it value because binary search trees have values. Nodes have values. And we're going to do self.node put value equals value, and we had self.previous and self.next, and here we're going to have left and right. So self.left equals none, just like before. Self.right equals none, again, just like before. That's it. We just finished programming node class in binary trees or binary search trees. As you can see, it's exactly the same. We just changed some of the names. Now we're going to go with the tree class. Let's call it tree. The name is more than enough. What we're going to start with, if you remember from the doubly linked lists, what we did was we started with the node class, a doubly linked list class, and the first thing we did was initialize the head. We're going to do the same in here, but instead of calling it head, we're going to call it the node. So again, $init that receives self, and in here we're going to do a very simple self dot instead of head root is going to equal none. So far, the exact same program from before. We just changed the names. Now, before I start, I'm going to add something new. Some of you actually did this in the last assignment, and when you look at the code, we said that we didn't check if the code was empty or not, if the doubly linked list was empty or not, because we wanted to get on with it. We didn't want to waste time checking for our class or checking our object if it's empty every single time. But one of the best things that you can do is actually create a method that you call that checks whether your code is empty or not. And I'm going to do that now. Define, I'm going to call it is empty. So is it empty? The answer is yes or true. That means it is empty. Your tree is empty. If it is not, that means it's not empty. There's something in there. Self, and we're going to call it. It's fairly simple. You just ask the question. So how can I know if my tree is empty? If we ask the same question, how did I know that my doubly linked list was empty? Well, we check the head. If the head was equal to none, that means there is no linked list. Well, we have something that is really similar to the head in here. So instead of asking about the head, I'm going to ask about the root. And I'm going to say, if self.root is equal to none, then all you need to do, forgot the colon, then return. That means it is empty. Else, which means the root is not equal to none. That means there is something, my tree is populated, it is not empty, will return false. And that's it. You can see, working with Python is simple, very simple. A lot of the codes that you scratched your heads at and you saw as kind of difficult at the beginning, we are reusing right now. If you know how to do a simple method, it's always going to be the same. So I have two methods. I have an initialization method that is giving root the first value of none so that it is declared. And then I have an isEmpty default method that is going to check. So if isEmpty, if the return is true, it means it is actually empty. If it is false, that means no, it is filled with nodes. And before I finish this video, I'm going to do a simple print. By the way, this week's lecture is going to cover three themes: how to print, how to add, and how to find. but we're not going to cover the delete. And I said this before. In the next week, we're going to do all of them, but in the real, actual way. The main reason behind structuring the lectures in this way is because you're going to see that all of the three methods that we're going to do in this week have recursion inside of them. So if you're not comfortable with recursion, you're not going to be comfortable with doing the delete, especially the delete because it's more complex than those simple functions. So we're going to go easy, which we did in the last week with the simple tree. We're going to continue right now with our simple binary search tree, and then we're going to finish in the next week with the real binary search tree. I'm going to do print. So define, let's call it print tree. What do I need in order to print? Well, I need actually nothing, just self, because it is going to print a tree that I already have. Don't. Now, in here, the thing that I just said was, I am going to print a tree that I actually have or don't. So I'm going to start checking for empty, whether am I printing from a tree that is empty or not. Well, instead of checking again, I already have the function in here, and it is ready for me to call it. So what I'm going to do in here is if self.empty, by the way, you know this by now, self.sorry is empty. So if this returns false, if self.empty means if self.empty equals true, it is not none, it is anything. I'm going to keep it like this, which means if self.empty is equal to true, or it is not none or not false. So if self.empty, what I want to happen in here is just to print a simple phrase that says you are printing an empty list, an empty tree rather. So what we're trying to do in here is print something, print a tree, and it is not there, it is actually empty. We should have something that come on the screen. This is one of the things that I saw with your assignments, which is some of the students would not do this. So if I test with an empty tree, this area in here is still white, and I don't know whether the program has frozen or it's going in an endless loop or whether it finished correctly. So you should always have those simple print phrases so that you can, or statements so that you can check your code. Let's continue. What if it is not empty? Well, in here, I'm going to call the real self.real print tree. And as you see, as you're going to see right now, I'm going to finish the code in here. So this function, this method is going to be finished in here. As I said earlier, we are going to do a simple type of encapsulation, which means I'm going to call a method. And if I pass the check, the function check or the method check, then I'm going to call the real method that does what I wanted to do. So the printing is not going to happen here. This is going to check and call. If everything is okay, it is going to call the real method, which is called the real print tree, because this one's called print tree. Those names are just names. Now, what do I need in order to print? The main thing that I'm going to need to send is the root itself. Why is that? Because the print is going to do a recursion. It's either going to be in order, post order, or pre-order. And what's going to happen is the following. Let's say that I go with in order. I have explained everything that I'm going to talk about right now previously in previous lectures. You can go back and check them as much as you want, as many times as you want. Just bear with me for the upcoming few seconds. What's going to happen in the code is the following. If I go with in order means print the left, then print the root, then print the right. And look at that. Print the left, then the root. Even if this part in here is the one that I'm printing, this one is going to be considered as the root. So what's going to happen is I'm going to send the root in here initially, number 10, and I'm going to call myself recursively, and each single time I reach a point, the point that I'm at is going to be considered the new root, just for printing, not the actual real one. This is just for printing. You're going to see that in code. So what I'm going to do in here is self.root. So the print done. I'm going to right now start coding the real print. So define real print tree. And as it is obvious from here, it's going to receive two things. It's going to receive self and why is that? Well, because this is just a name. This is just a name. I can call it XCV. You can call it whatever you want, but we are going to call it node. Simple node. And what's going to happen next is I want to print it. So first thing that I want to see, that I want to do is, of course, I'm going to do left. By the way, I'm going with in order, which means left. Then I'm going to do the data or the value or the print. Then I'm going to do the right. Okay. But before that happens, I need a condition to stop the recursion. If we do recursion or if we do a loop without a condition, what's going to happen is it's going to go endlessly. It will never stop. Recursion is having a method or a function that calls itself. The question is, when is it going to stop calling itself? So what's going to happen is I'm going to start with the condition. So I'm going to say if node is not equal, so if node is not equal to none, so exactly what I'm saying in here is while it is not equal to none. It's like having a while loop. While node is not equal to none, what I want to do is do an in order. So simply I'm going to call the left, so self.real print tree. I passed my node, so I have a node with the left and right, and I'm going to do node.left. I'm going to do, look, this is the left part of the in order. In order goes left, data or value, then right. Instead of value, I'm going to print actually my node.value, and then it's going to be self.real print tree or node.right. So back to this structure in here. What's going to happen is the following. I am the root, so I send the root, which is number 10. I'm the root right now, I'm in here. It comes in, it says, is node equal to none? While if node is not equal to none. So is this equal to none? No, it isn't. So it checks the first statement and actually call it. So it's going to call the real print tree on node.left. Which one is the left? It's the number 7. So right now, this came back here. So right now, this node is number 7, not number 10. It's normal recursion. And it says, is this none? No, it isn't. Check the first one. Again, jump to the left. Same thing happens in here. Jump to the left. As you can see, the left and right for this is none. You can see it in here. Self.left is none. Self.right is none. We didn't change them, so they are still at none. Okay? So it came here and said, if node is not equal to none, and in here it is. So it came back, and what happens is the following. We finish this. Okay, jump to the next value. So it's going to print number 0 in here and go on to the next one. Same thing is going to happen with the right. It sees that right is none in here. So call on the right for this part. Goes back here. Is node is equal to none. Actually it is. So it does nothing. Go back to the first one. Print data. Go to right. Left. Data. Right. Go back. Left. Data. Right. So on and so forth. So this is an in order. If I want to make this pre-order, all I need to do is move this from here. I'm going to cut and paste. So this is pre-order. I want to make it post-order. Cut and paste it here. This is post-order. I personally like in order. Don't know why. I'm going to keep it like this. As you can see, it is really simple. The main difficulty in this subject is that you need to understand recursion in order for you to understand how it is working. when you look at how programming is done, it is really simple. I have this method in here, and it is just checking. If it's empty, print statement. If it's not, call the function. And then I'm going to call the function, print data, call the function. So call for left, print, call for right, and that's it. I'm calling the same exact function, and as you can see, it's actually simple. If you understand recursion, this is a piece of cake. So to this point, I'm going to stop, and I'm going to start with the next video that is going to show you how to add. So for this video, thank you so much for listening, and I'm going to see you very, very soon.